And electronics, we used good parts because it's lasted for 20 years. It's still going strong. So.
But
Okay.
you made that in 2002.
It's older than that. Yeah, because I left the company in the fall of 2004. The date's on the sheet over here. So this is page 1 of 7. So this was March 96. So somewhere in that kind of 94, 96 range is when it was designed. All right. We're supposed to, again, find the limit as x approaches 0. So we're not going to do the blue step. We're going to do the green step. So factor and divide. Hands up if you can tell what factors out. Hands up. What do we factor this time? So Luke?
X squared.
Nicely done. How many new? 0.2 for Luke. So make sure you put equal because this is equivalent. Limit. X approaching 0. Make sure you write the limit statements. You don't write the limit statements, they don't give you the point. Like, it doesn't make any sense without it. I think they'd be okay with that. I can't remember even what the standard is. I don't think they'll complain. Yep. Good question. 2 more. I'm going to skip a step here. I'm going to note that I'm going to factor a x squared from top and bottom. So to make the work go a little faster, you can do the same. They won't care. You can separate the factors now, like this. Please.
Can we factor 3x squared on the top?
Oh, awesome. 2 more. The answer is yes. I choose not to. Who knows what? Let's go, Wesley.
Because you're going to factor x squared on the bottom too, so there's no point in doing 3 because it's just going to go back in.
Yeah, I'm always looking to factor and divide, pretty much. And since I can't factor 3 from the bottom, I got no reason.
Okay.
Oh, 2 points if you knew that, and Wesley gets 3. Questions? Cool. So this becomes simply 1 plus 6x. Questions? Please.
The one came from X squared.
Do you see it? The key is equivalence again, Jessica. Remember, this is being multiplied by this, which means if we were to multiply them together, the x squared would have to distribute. Does that feel good to you?
Yes.
So that's where I have to have the 1. Yeah, good work. Your comment, that is a really common mistake, is to forget that. Well done.
Do you have to write it in that order because technically the highest power is on 6x?
Oh, 2 points. We kind of all get raised in an environment where we just deal with math teachers, and they have this thing of like, oh, we got to put it in the right order.
Yeah.
That's just a tradition,
Okay.
not a requirement. Good question, though. It's a tradition, but you don't have to.
But it can work
Mhm.
either way.
Yeah, because they're just adding.
All right.
2 more. There you go. Cool. All right. So once again, using Jessica's flashcard, 2 for her, we have something divided by itself. Jessica, do we care that do we consider it 1 or do we consider it undefined?
1.
Because?
Undefined, it could be 0 over 0.
Correct. And in this case, it's not 0 over 0. Why?
Because something by itself. Something divided by itself.
I kind of confused you. I apologize. In this case, it's not 0 over 0 because we're doing a limit. And so we're not considering x to ever be actually 0, just close. 2 more. Cool. So that means we're really just finding the limit of this. Actually, I don't want to rewrite that. I want to stay here. I think it saves writing, and it also promotes better understanding. So now you just find the limit. Just plug in a number that is close to 0. It has to be a little more or a little less. Got to think of both sides. Raise your hand, please, if you can tell me what will we get for this if the x we're plugging in is either a little more or a little less than 0. There we go. Let's go, Luke. Shoot. Luke is your brother. Tucker.
Around 12.
How many got? Around 12. Point. I'm giving Tucker 3 because, no, I'm serious. I love the fact that you said around 12. We don't get 12. We get really close.
Could you explain why we don't do like kind of like the order of operations with the exponent first? So we would like square the almost 0 to be. Oh wait.
Keep going. You're doing great.
Never mind. Because when you square 0, it's 1, but when you square something close to 0, it's still something close to 0.
0 squared is still 0. Maybe. I don't know. Yeah.
Oh.
Pretty sure. Yeah, 0 squared is still 0.
Yeah, it's to the power of 1. It's to the power of 0 that turns it into 1.
That's right.
It is a bit confusing, but yes.
Okay.
Yeah.
That's
I was a little.
Yeah,
I
I know what you're
was-
saying.
What?
You're saying, okay, 0 to the 0, that's 1, which is kind of interesting.
Yeah, that's what I was thinking.
0
Yeah,
squared is still 0. Yeah.
Okay.
That fooled me. It's good work. More, please.
I might have missed this, but
You're
how
good.
do you know what number to plug in to find? So like he came up with 12, how did how?
We're always checking this. So he's thinking of two numbers. This one, that negative's kind of in a bad place. Hold on. So he's thinking of that number. Not what I wanted. Try again. He's thinking of that number and this number. And because remember the big idea, we have a formula right here, and we're just investigating. That formula is for finding y values. We want to investigate, one second, Isaac. What will that formula give us if the x is one of these? That's all we're doing. The only reason we factored is to make it easier to see what's really happening.
I realized my
Oh, cool.
mistake.
Two more.
I was thinking that you were going to do that. I just forgot for a moment that you're doing only one of those at a time, and so I'm like, if you divide the negative by the positive, then it wouldn't.
Oh, fair. Yeah, no, good work.
But then I remember.
Two more. Hey, look up here. 1 second. Look up here. Look up here. If you try to solve the problem from the very beginning, you run into a dead end. Because if you plug in a number really, really close to 0, just say it out loud. What will this be? Say it.
really, really close to 0.
Really close to 0 is the key. It's not 0, it's really close. What will this be? Say it. So what's really close to 0 added to really close to 0? Really close to 0. Does anyone happen to know how close to 0 it is?
Like 0.0 being 1.
Yeah, but precisely we don't know exactly. We just know it's really close. Okay, listen close to this. The same thing happens on the bottom. And here's the problem. You don't have a flashcard that says really close to 0 divided by really close to 0 is 1. Here's an example. This is close to 0. This is also close to 0. But the entire ratio is not close to 0 at all. So you cannot solve the problem from here. It's hopeless. You have to factor. Once you factor, there's no ambiguity because it's the comparison thing again. When we have this being close to 0 and we add it to 12, we know that numerator is dang close to 12. The bottom we know is dang close to 1, so the overall limit is simply 12. Question, please.
That was my question. Like, if it's dang close to 12 and dang close to 1, why do we say, like, the solution to the limit of x as it goes to 0 is 12? Like, when we say that, do we mean it's real close to 12? Or, because it feels like when we say that, it's just like, it's 12, there's the answer.
3 points. See if this helps. So Eli, if we're talking about the actual y coordinate, our answer would have to be dang close to 12. If we're talking about the limit, our answer is precisely 12 because of the difference between finding the y coordinate versus finding the limit. Okay,
Right.
Two more. Please.
So you don't have to write the limit x approaches 0 on the final one?
No, hey, look up. On the first packet, which I call the buff packet, you had to write those limit statements because I was training you for AP problems where they will require the limit statements. So I wanted to get in your mind that that is sometimes required. When they ask you to simply find a limit, I think you should write this one line so you can clearly analyze what's going on. But after that, everything else can be done in your head. And you can just write the answer. If you write more, it's okay, you don't have to.
Okay.
Two more. Jessica, please.
He explained
Austin,
it, and
there you go.
I think it made sense, but you're essentially just plugging it close to 0 as x, right? And then that gives you 12. So the bottom will be 1, 12 over 1 is 12.
Perfect. Yeah, two more.
Makes sense.
See if this helps, Jessica. No, really, see if it helps. It's really no different than what we did like several years ago, where they said, hey, we're going to plug in an x, we're going to get a y. The only difference is the formula is a bit too complex to just plug it in. So we factor first so we can see better what's happening. That's all we're doing. That's a good question. Anybody else? Hey, key to this class. You just get good at talking with me, you'll be fine. It really is a key. I don't know that I've ever had a student who could converse calculus with me that did not do well on the AP test. Just keep talking. And if I ever do something that discourages you from talking, please have the courage to send someone to tell me, don't do that anymore and I will stop. Like I try desperately to do everything I can to keep you talking. We good there? Okay, now we need to do that, like Michael said, the other part of the problem, two more for Michael. We gotta go find the asymptotes. So here we go. That means we gotta find the limit as x approaches infinity. We have several formulas to choose from.
Huh?
And negative infinity. Is that what you said? I heard voices. No?
Yeah, he was. Never mind.
Moving on.
I'm real confused.
Moving
He
on.
said something and I didn't know what it was.
No worries.
But like, let's just keep going.
Going. I don't want to use the first formula.
You don't need to say.
Let's use the second one. And really, so Jessica needs to make a sign now. I'm a shameless sign beggar, sorry, you can see it. I really don't get that many each year, it's like maybe one or two, but I much prefer to have a student sign on the wall than something I made. It's way more interesting. So we need to, let's see. It's got to go with either Condi or Jessica. That's funny. I'll work on it. Got to have a nice slogan. So, but the whole something divided by itself is 1, unless something is 0. Cool. So we can forget about this because we're going to investigate what's happening when x is large. It's going to be 1. So we need to find this limit. Draw a line, it's a new problem here. The limit as x approaches infinity of simply 3x squared plus 12, 1 plus 6x. Using this blue rule, I can say equals the limit as x approaches infinity. And what's the new fraction that I write? Hands up. There we go. So let me get everybody to raise their hand. So using the blue rule, what's the new fraction that I'm going to write? What's the new fraction I'm going to write this time? So I compare terms that add, Emmeline, what do I write?
U 3x squared over 6x.
Nicely done. And to save a little time, I'm going to go ahead and break it up. 3 over 6 multiplied by x over x multiplied by x over 1. So I was able to do the negligible thing by comparing these two terms. 12 is negligible compared to the 3x squared. And the same, similar on the bottom. And then because I have factors, I can list them separately. 2 points, 1 if your hand was raised. Questions? Please.
So like on the last problem, when we dropped like those other four numbers, did we drop those because like they weren't like big, like when you have infinity as x, and we just kept that one too because they were the x squared?
It's all about the comparison.
Okay.
So yes, on the other problem, it looked like this one, Emily. We had 3 terms that we were adding, and because they're all power functions, the highest power function is dominant. And when those 3 things are added, they do make a contribution. They just make such a small contribution that they aren't really significant. Does that help? 2 more. Back here, questions? So, that's going to be 1/2. That's going to be 1. Here's the interesting part. As x gets bigger and bigger and bigger, what happens to this?
It gets bigger and bigger.
Just gets bigger and bigger. So you would write as x approaches infinity, y is going to approach, let's see, this is just really big. It just gets bigger and bigger and bigger. So these don't really have any contribution. So this is going to be infinity. Please.
Don't you need to write infinity?
Say it one more time, sorry.
You forgot. I think you forgot to write the infinity to the letter x.
Oh, true. 3 for Wesley. Squish it in there. Sorry about that. Well done. Anybody else? As x approaches, we don't care. Yeah, no, sorry, I was just saying.
Sorry.
Yeah, my bad.
Sorry.
Sorry.
I wasn't sure if you were
You're good.
doing that.
You're good.
So would we have to do the negative infinity too? So
Uh-huh.
as x approaches.
Yep. And that's preparing you for AP questions where I've seen both come into play. Strictly speaking, it feels like 90% of the time they only care about positive infinity. But of course, to keep you honest, 2 or 3 years ago they threw in one that was negative infinity. Please.
Would you have to put like the therefore 3 dot triangle thing on that?
You could, not required. 2 points. Please.
So I thought you said this one doesn't have a horizontal axis, so it doesn't technically.
It does not. Hands up, what am I going to put here?
Infinity.
What goes here, hands? What goes there? Let's go here.
Negative infinity.
Nicely done. This is still going to be 1/2. This is going to be 1, but this is going to be negative infinity now. Which means the graph does this kind of a thing. Right? See what I'm doing?
Yeah.
Does that make sense?
Yeah.
Okay. Usain Bolt. Okay. My bad. Yeah, it's a decent joke. That wasn't too bad. Questions? Please.
So I'm still confused why x only 1 turns into.
Oh, no worries. Are you okay that if we were to multiply the green box times the green box? Okay, first thing is I kind of left out a step. Are you okay that we are ignoring the 12 and the 1? Good. So, Jenna, what's 3 times x times x?
Yeah, so you broke it down.
Okay, so you're good there. Awesome, just making sure. So now, all I'm going to do is say, if x is big, like it's 1,000,000, what's this, just stay with me, what's this going to be, Jenna?
1/2.
Good. What's this going to be?
1.
So 1/2 times 1 would be awesome. But this will be 1,000,000 divided by 1, which is, so I'm going to have 1/2 times 1,000,000, which is 500,000. So when I plugged in a big X, I ended up with a pretty big Y. If I continue the pattern, because going to infinity means just keep going, so now I'm going to plug in 1,000,000,000. What will this be? This will be, and this will be. Good, so when I multiply them together, I get 500,000,000,000. So now I have the pattern. Every time I plug in a bigger x, I just get a y that's half as big, but it's still big. So as x grows, y grows with it. Did that help?
Yeah.
2 more. Please.
So couldn't you also say that infinity divided by 2 is just infinity?
That's the whole problem, is it's just this idea. It's not really a number, it's just saying, hey, as the graph gets more and more this way in x, the y just keeps climbing. It doesn't climb as fast, but it does keep climbing. So these are not horizontal asymptotes because we're not approaching a finite number. we're just climbing or dropping. Did that answer your question? Okay. Anybody else? So you just write no horizontal asymptote. Please, Mike.
Are we supposed to know how to identify a slant asymptote?
Not for this class. I've never seen that happen ever. Just not a part of what we study. So I don't review it. Yeah, I've never seen it. I've worked really hard for all 16 years to like really pinpoint what we should focus on. So. Questions? Cool. Stop that one.